Your engine displays puzzling behaviors, guzzles fuel at an alarming rate, or produces concerning exhaust emissions that worry you daily. These seemingly complex warning signs often mask a straightforward repair solution that I will reveal completely in this comprehensive technical investigation. The mass airflow sensor, commonly abbreviated as MAF sensor, stands as one of the most critical components within modern fuel injection systems. This sophisticated electronic device precisely measures the volume of air entering the combustion chamber and relays this vital data to the engine control unit. Using this accurate information, the ECU can meticulously adjust fuel injection quantities to maintain the optimal air-fuel mixture ratio consistently. Without this constant calibration, your engine would operate with either lean or rich mixtures, causing severe operational failures throughout the system. Sudden power loss during highway driving represents the most dangerous symptom of a failing MAF sensor that drivers encounter. When this sensor provides erroneous readings, the engine control module loses its ability to properly balance the air-fuel ratio. This disruption creates incomplete combustion that manifests as violent jerking motions, particularly noticeable during steady-speed cruising or gear transitions. Engine hesitation during acceleration constitutes another early warning sign that experienced mechanics recognize immediately in their diagnostic procedures. Picture attempting to merge onto a busy freeway when your vehicle stumbles at the most critical moment of acceleration. This dangerous response stems directly from improper fuel metering that prevents the engine from developing its rated horsepower output. Rough idling patterns indicate MAF sensor deterioration and require immediate attention to prevent cascading system failures throughout the powertrain. At idle, engines demand extremely precise fuel dosing to maintain smooth operation without fluctuations or irregularities. If the MAF sensor underestimates actual airflow, the PCM reduces fuel injection proportionally, creating an excessively lean mixture. If you find value in our technical automotive content, please subscribe to our channel and activate notifications to support our specialized engineering analysis. Complete engine stalling represents a more severe consequence, especially common in vehicles equipped with older fuel injection systems. Modern cars incorporate multiple backup sensors that partially compensate for these failures, but a completely failed MAF sensor can cause unexpected shutdowns. This problem creates a domino effect throughout the entire fuel delivery system, as a defective sensor can disrupt oxygen sensor operation and damage the catalytic converter prematurely. Excessive fuel consumption logically results from incorrect air-fuel mixture calibration caused by faulty MAF sensor readings. A sensor that underestimates actual airflow pushes the ECU to over-enrich the mixture, dramatically increasing fuel consumption rates. This efficiency degradation not only creates additional costs at gas stations, but can also cause failures during emissions testing procedures. Black smoke emission from the exhaust pipe provides unmistakable visual evidence of an overly rich fuel mixture condition. This incomplete combustion generates carbon particles that evacuate as dense, foul-smelling smoke through the exhaust system. Beyond environmental concerns, this phenomenon can irreversibly damage the catalytic converter, whose replacement can cost up to $3,500. Abnormal knocking sounds, commonly called engine ping, manifest as distinctive metallic noises originating from the engine compartment. These phenomena result from disorderly combustion caused by improper air-fuel ratio management within the combustion chambers. If these detonations persist untreated, they can damage pistons and rings, leading to repairs exceeding $4,000 easily. The check engine light does not activate systematically during MAF sensor failures, contrary to popular automotive misconceptions. When illuminated, specifically search for error codes P0100, P0101, P0102, and P0103. Air-fuel ratio codes and misfire-related error codes may also appear simultaneously during comprehensive diagnostic procedures. To effectively diagnose a malfunctioning MAF sensor, employ an OBD scanner that displays real-time data during various engine operating conditions. At idle, the sensor should indicate approximately 0 grams per second, increasing gradually with engine speed increments. If values remain static or fluctuate erratically, the sensor likely requires immediate replacement to restore proper engine operation. The disconnection test represents a simple yet remarkably effective diagnostic method that I regularly employ in professional practice. With the engine running, disconnect the MAF sensor electrical connector and carefully observe engine behavior changes. If engine performance stabilizes or improves noticeably, This conclusively confirms sensor failure and necessitates replacement. The tap test involves gently striking the sensor housing with a screwdriver handle while the engine operates normally. If this stimulus causes RPM variations, stalling, or uncontrolled engine racing, the MAF sensor contains internal defects requiring immediate attention. Cleaning the MAF sensor can occasionally resolve issues temporarily, though this solution typically provides only short-term relief. Carefully remove the sensor from its housing and clean sensitive elements using isopropyl alcohol or specialized products like CRC MAF cleaner. Absolutely avoid touching the heating wires, which are extremely fragile and expensive to replace if damaged accidentally. Allow minimum 20 minutes drying time before reinstallation to prevent irreversible damage from residual moisture exposure. The automotive industry primarily utilizes 3 distinct MAF sensor technologies depending on manufacturer specifications and design requirements. Hot wire sensors measure airflow by adjusting current necessary to maintain constant temperature across a resistive filament element. Hot film sensors employ a more durable resistive membrane, while older vane-type sensors operate using purely mechanical measurement principles. Replacing a MAF sensor typically costs between $250 and $470, including professional installation labor. The component itself represents approximately 2/3 of this expense, ranging from $200 to $300 depending on vehicle specifications. The installation procedure remains relatively straightforward and requires maximum 1 hour of work by a qualified automotive technician. To maintain optimal MAF sensor condition, regularly replace air filters and avoid intake system modifications that could disrupt measurement accuracy. Preventive maintenance every 6 months with gentle cleaning can significantly extend the service life of this essential injection system component. Do not wait for symptoms to worsen, as a completely failed MAF sensor can damage other expensive fuel system components. Prevention remains your most effective strategy for avoiding these costly and potentially dangerous automotive failures that compromise vehicle safety. Regularly inspect intake, ductwork condition, and verify sealing integrity of all connections between the air filter and throttle body. Parasitic air leaks can falsify MAF sensor measurements and produce identical symptoms to actual sensor failure conditions. Diesel vehicle owners must pay special attention to MAF sensor contamination, as soot particles accumulate more rapidly on sensitive elements. In exceptional cases, an apparently defective MAF sensor may reveal more complex fuel injection system problems requiring comprehensive diagnosis. A failing fuel pump, contaminated injectors, or inadequate fuel rail pressure can create similar symptoms and confuse diagnostic procedures. Therefore, complete diagnosis with professional equipment remains essential before undertaking any expensive component replacement procedures. Vehicles equipped with turbochargers present specific considerations regarding MAF sensor operation and potential failure modes. Boost pressure can amplify consequences of sensor failure and cause significant mechanical damage if problems remain untreated. Experienced technicians utilize oscilloscopes to analyze MAF sensor electrical signals and detect intermittent failures invisible to standard testing. This advanced methodology identifies problems that do not appear during traditional static diagnostic procedures or basic code reading. The future of MAF sensors trends toward contactless technologies utilizing ultrasound or laser beams to measure airflow without physical contact. These promising innovations will eliminate contamination problems and considerably improve durability of these essential engine management components. If this specialized technical analysis has proven valuable, support our channel by subscribing and activating notifications to discover all our upcoming automotive engineering investigations.